Hello, everybody. I'm Matthew Blain, and I'm a member of the Google App Engine team and one of the engineers on it. And I'm here to talk to you today about the bulk loader. The title of this talk is Data Migration with App Engine. So you can follow along with the presentation. They'll be taking notes on Google Wave, and you can also find sample code, which I'll be referencing throughout the presentation on bulkloader sample.appspot.com, or again, you can look at the Wave at bit.ly/appengine4. So I'm going to give you a bit of background about the bulk loader and what you need to know to understand the bulk loader, tell you a bit about how the bulk loader works, show you how to create your own configuration for the bulk loader, talk a bit about some of the advanced features you'd use to create sort of more complicated configurations, and tell you a bit about troubleshooting and the future directions for the bulk loader. All right, so what is the bulk loader? How many of you have actually used the bulk loader in App Engine? All right, good number of you, that's good. So the bulk loader is a tool for data store import and export in App Engine. So you can use it to import data set into App Engine from like CSV file, an external database or something. You can export out of App Engine, similarly to a CSV file or external database. You can also use it to migrate data between application instances. So for example, people have demonstrated you use like a QA server and a production server. If you've set up QA, you can move it to your production server. You can also move between dev app server and production, which is also particularly useful in QA. Even though the title of this talk is Data Migration in App Engine, it's not really about schema migration, though I suppose you could use the bulk loader for it by downloading all of your data with one schema, then uploading it all with a slightly different schema to a different kind. It's not meant for that. It could work for it. So again, I'm going to sort of show you how to configure and use the bulk loader. So just a bit of background. I'm guessing everyone who's used the bulk loader has used the App Engine data store, but how many of you are familiar with the App Engine data store? Oh, pretty much everybody, that's good. But just a bit of review. Basically, you have schemaless tables of entities. Every sort of table in relational terms is one kind of entity. It's called an App Engine. Every entity is a single key, which is the identity of the entity, so you can fetch an entity by keys. There's also indexes, which you can use to sort of, well, if you want to do other queries more interesting than just get me the key X. And keys are not really hierarchical, but they're actually, you can have, for entity groups, this will become important later, you can have parent keys on your keys. And properties are types, so there's no schema on a kind, but typically you have a bunch of different properties on an entity, and they have particular types, they're not all strings. In Python, you wrap this with the model class. In Java, you can wrap this with the JDO or JPA or whatever annotations. And there's other wrappers for other languages, which people have running on the JVM and App Engine. So the fundamentals of what the bulk loader does is it takes your data from your external source, converts them all to the data store entities, the type that are used in App Engine, and then just ships them over to the data store on HTTP. One thing that's sort of important to note is that the bulk loader is actually running on your client workstation. This is how we get around things like 30-second limits and small amounts of upload, is that we do the primary work on your local workstation, then just ship the data off to App Engine. And just a bit of background, you obviously need an App Engine app to run it. You can run on dev app server or on the production. One of the frequently asked questions people have is, does it only work on Python, or do you have a Java version available? And the answer is that the server runs either on Python or on Java. The client, however, we only have one client right now. It's implemented in Python, so you need the Python 1.3.4 SDK, particularly for the new configuration format I'm talking about today. You'll need the newest version of the SDK, and you need Python to run it. You don't need anything else. You don't need any particular IDEs or anything like that. All right, so how does the bulk loader work? And just a quick demo. Actually, before I even get to that, I just want to remind people about zero configuration. This feature's been out for a little bit. But as I mentioned, particularly if you're migrating data from one instance to another, or you just take a daily backup or something. For example, if it's a good thing to do before you do a schema migration. You back up all your data in case something goes horribly wrong. You can just dump your data from App Engine to your local workstation. One thing which is somewhat new is that this is fully integrated in AppCFG right now. You can also use the bulk loader. But basically, you just run this command, AppCFG, download data, point to your application, point to the local file name, runs, and the inverse upload data. All right, so I'm just going to do a quick demo using the new configuration format, which came out in 1.3.4. All right, so my wonderful demo system. All right. Just bring it back for a second. So I'm going to be demoing with the guestbook application. This is the same application that you see with either of the Getting Started guide for Java or for Python. So I have just some very simple sample data. The guestbook has just comments, date the comments were written, the author who wrote the comments. So I'm going to upload the data. All right, so upload data command. It's got lots of command line arguments, but basically it says, here's the file, here's the configuration, here's the destination. And if we actually look at our guestbook now, it has the same exact same comments we just uploaded. I can say something else. Hello, IO. Good afternoon. And we can also download them pretty much the same way. All right, so here's the downloaded data. You should see hello, IO, good afternoon right there. So how did that work? So sample data, we've got the model. This is the model many of you are familiar with if you've gone through the sample. And this is the same thing in Java, right? They're exactly equivalent applications. I happen to be running the Python one here today. So how did it work? So this is described. This is the new configuration format. This is probably the first time many of you have seen the new configuration format. It's designed to be declarative so that if you're a Java developer or some other language developer, not necessarily a Python developer, you don't actually need to understand Python. It's still somewhat based on Python, but the fundamentals are designed to be just basically declarative. So we've described that we have a kind greeting, that it came from a CSV file, and it has 3 properties. Basically, the first property is just a string. Second property is a user property. Third property is a date. And dates are a little bit more complicated because we have to define the format the date is in, because CSV files are strings, and dates are internally or offset from an epoch or something like that. So the way it works is that the bulk loader is a 3-phase process. There's 3 transitions. This is the first 2 of the transitions. So on import, we have our data, it's CSV file. See, it's cool stuff, comma date, comma some author. What we have is called a connector for the first phase. So the connector takes the data from the external format, in this case CSV, and converts it into what I call a neutral dictionary. The dictionary is just a dictionary of key value pairs representing each row, basically, in your input data. The reason for this intermediate format is that we can have different connectors, not necessarily CSV, but any format can output a neutral dictionary to pass on to the next stage, which is basically what the property map described us to do, where we transform this dictionary into a data store entity. So you can see that the property, the YAML file, we described that content had no transform. The date had this transform with this string specifying the date format, and the user just specified the user property. So we pass them into these 3 arguments, and then we basically get an entity, which these are a Python representation of the type data. Again, a string, a date, and a user property. The next phase, as I mentioned earlier, we've run this on the client workstation, and now we're going to upload it to the server. So this uses Remote API. Many of you are probably familiar with this, but basically every single API call in App Engine, in fact, is an RPC. So what Remote API does is we're actually running basically the full App Engine stack, similar to the Dev App Server, on your local client workstation, and the data store calls are remoted using Remote API to the server. The other interesting thing to note about the upload part and this whole process is that it's actually done in parallel. We run multiple threads. The default's 4 threads, so I've got 4 clouds here. On upload, because it has all the data locally and it's pushing to the data store with identified keys, talk about that in a minute, it does the full conversion process in parallel. On download, because you want the order of your output file to be the order of your original data, it actually downloads all the data locally and then runs over this transform step after it's done downloading all the data. The other piece, you need to enable Remote API. This is sort of a quick reminder. You can see this in the documentation. I'm showing it here partly because the most common error that people make when they turn on a Remote API is that they have some sort of catch-all handler in their application, and they put Remote API after it. So simplest advice, just put it first thing in your app.yaml or first thing in your web.xml. This is the equivalent, exact same equivalent in Java for handling the exact same case. All right, so how do you create these configurations on your own? It's probably the most important thing you'll get out of this talk today. So it's sort of a big wall of text. I just showed you the sort of the key piece of the configuration for the guest book. But if you want to write it yourself, we've actually provided a wizard to create it. So any of you have any ideas on how it gets the data to actually create those texts? Yep, stats. All right, you got it. So the data store statistics are a feature that's been in App Engine for a while. You've probably seen them in your admin console. It says, here's how much data you have of this kind. Here's how much data you have of this property, this type of property. The data store statistics are actually themselves stored in your data store. So if you're interested in seeing sort of a slightly more complex bulk loader configuration, you can actually look at how the bulk loader creates the bulk loader configuration. If you don't care, you can just use it. Don't worry about it. But basically, create bulk loader config itself actually uses the bulk loader to download your data. So again, just a quick demo. This is the command line appcfg create bulk loader config. One of the disadvantages of using data store stats is they're only available on production, and they take up to a day to generate. So if you've modified your schema very recently, you basically have to wait a day to use the bulk loader. You'll just have to fall back to editing the file yourself, I guess. So here we go. And here's the auto-generated file. This is, in fact, just what was created right now. You can see I have there's just a bunch of boilerplate at the top, some instructions, and then there's the several different properties which I have in my demo app, or several different entity kinds I have in my demo app, which you can modify. All right. So what do you need to do after you've created the auto-generated file? It's not completely automatic, right? You're not totally done, but actually in many cases you are already done. If you have a simple enough schema like the guestbook one, quite possibly all you need to do is set the connector. So in this case, I'm specifying connector CSV where it said to do, and the default options for some of the connectors are pretty simple. It's pretty common that default encoding for them is UTF-8 on all the ones that we're shipping right now. CSV files are pretty frequently in Windows 12.52, so you might want to add encoding Windows 12.52. And you also want to review the property map. That's the most likely thing you're going to need to do next. So keys are actually really interesting. I'm going to spend a bunch of time talking about that in a few minutes. You also may need to check for duplicates. Pretty rare, but if you have, when your data store statistics, if say you've had a schema change and you've changed specifically from the phone number type to a string type or vice versa, you may have some entities which the data store statistics have noticed, which are the old types. You just need to go and delete that. And there's a bunch of to-dos that you have to deal with. So let me talk about keys for a minute. So if you're used to the relational model, you have primary keys and foreign keys. Not quite the same thing in App Engine. This is the schema for basically a SQL schema similar to the app that's on bulk loader sample, which I just created the wizard for. So instead of a primary key in App Engine, again, every entity has a key. Called as a primary key. There's also references. You may have seen the talk about the corporate applications we built at Google. They talked about reference keys in some of them. And you can basically use a key to identify another particular entity of another kind. And there's also entity groups, which I mentioned earlier. These are typically used for transactional reasons, but you may, in fact, use them for actually structuring your data, and particularly in Java, their own relationships. And also just a reminder for those of you who are familiar with it or something new for those who don't, when you have keys on your entities, there's basically two types. One is the auto-generated key. If you don't really care about the key, what it means, App Engine will auto-generate one for you, which is a number associated with it. The numbers increment over time, approximately. No particular guarantees about them other than being unique. You can also have a developer named key. This is particularly useful if you care about your key structure. There's something really easy to calculate to identify a key. Say you have a blog with posts on it or Wikipedia articles, or you have a user object which represents a particular user. It's often really useful to use for example, if you use the Google Accounts API, we give you a unique user ID for every user. You can just use that as the key. And it's really useful because if you have any other instances where you have this thing which you can identify, you can then look up whatever you want just by key. And these are also particularly useful for creating relations. So again, if you have a bunch of tables and say you've exported them from a database in different CSV modules, you can then calculate the key so you can create your references automatically. So most common case is a key with no parent. The way you set the entity key is a pseudo property ___ key ___. This shouldn't conflict with any of your properties because we claim everything with underscore is reserved. So if you just specify a string on import, that will just create a named key. You do need to actually use transform. We've provided a bunch of helper functions. I haven't mentioned it yet, but there's a whole library called transform, which is imported by default in the auto-generated bulkloader.yaml. It's got a bunch of helpers. One of them is key or ID or name is string. This one's basically safe. If you happen to have a mix of IDs and names, it will just print out the ID or the name as a string. There's some other helpers if you want to distinguish between them in your output. And for reference properties, we also created another method, which is called create foreign key. So if the schema identifies anything as having a key in the data source statistics, the auto-generated YAML will actually just fill in the transform for you with the to-do. We have to specify the kind, and that's all you need if it's just a single level key. All right, so this is an example from the schema. We've got a customer and a visit. Every visit has one customer. And we have an external visit ID. The export, I know it's always named, so I can actually use a simpler key name. I should have used the example which I had before. And then it has a customer property, which in this case has an external name of customer. This is just supposed to be this is the name part of the customer key. So again, transform create foreign key customer. We'll just generate that. And the parent keys I mentioned are used for creating entity groups or own relationships. So you probably actually shouldn't do this. I'll explain that you should probably be using list properties for this. But let's say you wanted to actually have the visit and the visit activities represent exactly the schema, where we have a visit and a visit activity to handle the one-to-many relationship. You can do this by creating an entity group for each visit. And we've provided a bunch of helper functions, again, this transform method, which I call to create deep key. So every key is identified, every level of the key is identified by the kind and then the identity. So in this case, this helper function knows how to pull out the visit column associated with the visit kind, pulls out the activity column, associates it with the visit activity kind, which is, in fact, not listed here, but it's the kind that we're importing. And on export is actually also the first time I've shown this to you guys, which is that since this is a multi-column thing, we have one key, which is represented in the CSV as two different columns. On import, there's one function which knows how to actually look at the whole row sort of holistically and actually pulls out the different columns it needs to create the key. On export, we actually can specify two different exports. So we have the export to the external column visit, export to the external column activity, and they have two different transforms which run the function, just pulls the key apart. So as I mentioned, you probably don't actually want to use an owned relationship for this very simple visit activity. You actually want to use the much more efficient list property, which is present in App Engine, to generate, just put them all in the same entity. So when you fetch the entity, you get all the data. So if you know your schema, you'll know this when you're editing the file, but you may have forgotten about it. You may just be reviewing the auto-generated YAML file. The statistics, unfortunately, don't actually know about list properties. What they do know is sort of the count of properties you have of each kind. So in this case, we have about twice as many activities as we have customers. So there's a good chance the list property, you should obviously review your own model, your own Java annotations to verify this. But it's a sort of a glaring note that, by the way, this one's special, and you should probably do something with it. So what do you actually do with it? Again, this is sort of the simplest way to deal with it. If you have something like a CSV file, and you've already auto-generated it in some system, if you have one of the columns is itself some sort of delimited column, in this case I'll use a semicolon, it's different from a comma. Provide a helper called split string join list. Because these are typed properties, these helpers will return a list of strings or take a list of strings and split it out. These are actually typed, so if you do something else, a list of integers, you actually want to do something slightly different. All right, so that's sort of just a basic overview of how you auto-generate a YAML, some of the things you want to do when reviewing it. It'll auto-generate sort of the most basic types. These are some of the transforms. You'll want to look into the transform class to actually see a list of some of the other transforms, and we'll be providing more later. So let's talk about some sort of more advanced configuration. Multiple tables. Again, let's imagine we have this visit activity table, and it's actually represented as two different tables in say, a relational database. And you don't necessarily want to actually write the pre-processing to smash them together. How do you handle that? Right now, actually, the example I'm going to give you actually sort of is cheating on this. It actually does use some sort of pre-processing. If your database or you have a tool which exist can output in hierarchical format. So instead of just taking like a CSV file and smashing the hierarchy into it using semicolons and hoping you get the escaping right, if you have something like an XML file, we actually provide also an XML connector. So since this is natively hierarchical, we can do something much more interesting with it. So this is just a quick intro to the XML connector. It's called Simple XML because it only handles really, really simple XML right now. Someday, you can imagine someone writing a more complicated one. But basically, you provide the XPath, which represents each of the primary entity. In this case, visits. Visit is the XPath. There's multiple visit nodes you can imagine. And it handles both element-centric and attribute-centric. But for this case, we're going to use an element-centric schema. Then we have the list property. So all the other properties I've elided here, they work just like before. You say that, whatever the primary key, and et cetera. But what we can do is we say this activities property, which is a list property. Again, I'm just going to provide a helper here, which says list from XML node. You may want to look at the source of the helper. It's kind of interesting. I'll go into later how it actually works. But basically, again, it looks holistically at the thing similar to the way the create deep key worked. And it actually looks at the XML node, runs a different XPath on it for the activities, pulls out all the activities, and generates a list out of that. And on export, it does sort of the inverse. It takes all the activities and actually converts it into a list. So the neutral dictionary, for a CSV file, all of the items in the neutral dictionary are just going to be strings. But for other file types, it's actually not necessary that the dictionary only have strings in it. In this case, Simple XML supports on output. If you have basically a dictionary as one of the items in the dictionary, it'll actually create the child nodes for you. So that's what this transform helper on export does. It actually puts a dictionary in the dictionary recursively because it's recursive format. So how does this work? How would you write your own code? I'll go into that. So this is the first time I've actually shown Python code here. Since the bulk loader is written in Python, you will need to at least have some basic understanding of Python. So this is sort of a composite slide of 3 different ways of doing the same thing. So you can actually have an inline lambda in your transform. So similar to how if you just specify, say, int, that's actually the Python int conversion function. You can specify a lambda function. So in this case, I've just specified a lambda, which takes the value, which is passed in, converts it to an integer, multiplies it by 2. You can also do something very similar to the transforms we've provided in the transform.py or the sample transform helper.py, where if you want to do something multiple times, you don't want to just like copy and paste this lambda 50 times in your file, you can just define a function double. Again, it takes one argument, takes the value, converts it to an int, returns it. And then in your import transform, you just reference it. You import your module called double. And the third thing you can do, and this is what many of the transform helpers do, we're sort of going far more complicated here, is if you want to have a function which takes an argument. So in this case, this is a sample multiply function, takes a multiple, and actually returns a function using sort of closures in Python. So in your import transform, if you say my module multiply 3, we're now tripling instead of doubling the number. And my module multiply 3 is itself a function. So when we pass in the string, quote 1, 1, quote, it'll convert it to an integer triplet, and you get back 33. But that doesn't explain how the list or the deep key functions work. How did we actually get this information? Because they only pass in a single value, a single column. And the answer how those work is if you specify a keyword argument, bulk load state. Typically, it's the second argument, but it actually has to have explicitly that name. We pass in this bulk load state object, which lets you see the bigger picture of what's actually happening. So you get things like the file name, loader options, and export options passed in the command line. But more interestingly, you get the current dictionary and the current instance, which is being transformed. So when you're doing this, the way it worked with sort of create deep key, or the one which took the XML and converted it into a list, is that the function knew we provided an XPath into the XML node. We look at the bulk load state for the current dictionary, and the current dictionary in the XML converter contains the node itself as one of its properties. So we looked at that, said, OK, we're going to run this XPath on it, do a bunch of information, and return this list property. Similarly, for the one which created deep key, it actually said, OK, here are the columns I care about for my keys. It was visit and activity. It actually looked at the dictionary, said, OK, I'm going to look for the visit property in the dictionary, the activity property in the dictionary, combine them together, and create a deep key. In fact, here's a simplified version of create deep key. So again, this is one of these things which is in the closure so that it can be reused in multiple different YAML files. And we have a transform function, and we basically go through the list of kinds and columns that were provided in the YAML file and pull out the information from the dictionary. So the kind columns is something that would be specified in the YAML file, and the result is basically we take this, iterate through it, and it calls the key from path function, which is how you build one of these hierarchical keys in the Python datastore API. The other useful thing, so sort of mentioned you can sort of introspect into state on your transforms. You can also do a post-processing, this post-import function, post-export function. These will we'll pass in the entire dictionary, the neutral dictionary, and the entire entity in both directions. We pass both of them. And you can do whatever you want with it. So you could, for example, have nothing in your property map and have a post-import or post-export function which did all the work yourself. I'm not quite sure why you do that. More useful is that you can do filtering. So on import, you can say, OK, for some reason this is invalid or it's not something I care about. It's going to return none. Similarly on export. In fact, that's how the bulk loader takes the data source statistics and provides a useful bulkloader.yaml, because there's actually a bunch of noise in the data source statistics we just don't care about. So it just says return none on all of those. The other thing you can do on import, you can't do this on export, is you can actually provide a second kind. That becomes interesting if you're sort of doing data denormalization or normalization of some form on your imported function. It's not particularly easy to do right now, so I'm just going to skip over that other than mentioning it exists. So the other interesting thing is writing your own connector. So CSV is not the whole world, right? I mean, sure, you can export most databases into CSV, write some processing. Even XML, it's a very basic XML connector. You can do hierarchy. But let's say you want to talk with some other file format, like a database format, or even a connection to a live database, or even other websites. I think somebody asked some question about GData on the wave before the talk. You can write your own connector. There's a simple connector interface, although actually as we've been sort of extending beyond the simple model of files, it has some limitations, so it might change, but it'll certainly stay there as a backwards compatible version. So this is actually a complete connector on the screen right here. When you notice, for example, I set the encoding option on the CSV connector much earlier in the demo. The connector gets this when it gets there's a method you define to create your connector. In this case, it's just the constructor of the object. You can just get it from a dictionary. And on import, there's just one method which returns an iterator. In this case, generate import records. So I'm just reading JSON. So this format is particularly useful if you have something which can, say, export to a hierarchical format. Each line in the file represents a row, and each line actually represents a JSON document. So it's not actually one JSON file. It's multiple JSON documents in a single file. Open the file. For every line in the file, just run simple JSON, deserialize it, and yield it. It's a generator. It's a very simple way of implementing this. On export, very similar. There's 3 methods instead of 1. You've got an initialize method, so we just open the file. For every dictionary that gets passed in, we do something interesting with it. In this case, we just serialize it using simple JSON and write it on its own line. And when we're done, we close the file to clean up after ourselves. All right, so now you've sort of learned sort of how the bulk loader works, how to write your own connectors, how to write your own configuration file. I'm just going to go into a couple of tips about how to use the bulk loader. One of the particularly things that happens a lot when you use the bulk loader, because you're running on your client and because your application is sitting on a server, is things happen. It may get aborted. You may temporarily run out of quota. Someone may trip over the wire and disconnect you, whatever. You may have an error. You can resume both uploads and downloads. You don't have to just start from scratch. So on uploads, you need to pass DB file name. That's where the bulk loader stores its state about, OK, how far along am I into this file? What's going on? On downloads, you need to pass both the state and the result DB file name. As I mentioned earlier, it downloads everything, and then it runs it through the transform. This is also particularly useful on export. You can use this for a couple of things. You can, if you sort of just messed up your export transform, you don't need to re-download all your data. You can just rerun it, point it to the same result DB file name. It'll run over it. You can also do tricks where you use different formats. So if you've downloaded the data and want to run some sort of 2 different reports or something on the same data, you can specify 2 bulkloader.yaml files on the same result database. So talk about tuning. So I mentioned much earlier that it runs in parallel. And the downloads run in parallel, and the upload is run in parallel too. They're all run in parallel. There's a couple different arguments. These are just 3 of the common ones you need to deal with. Because of the limitations in quota on App Engine, unfortunately, frequently you need to tune these down to much smaller sizes than the default. However, you can also generally turn up the number of threads. So the bulk loader is actually making estimations on the client of what your server can handle. It's based on some of the rules and some of the quotas that we have. And actually, in the last maybe year or so since we originally wrote this code, some of the rules we've had have actually changed and relaxed. So its estimation's often off. So unfortunately, it usually just works, but occasionally to tune it. So a fairly common tuning operation is to turn down the number of requests, the number of data that's sent at any one time, and turn up the number of threads so you can do more things in parallel. You can also, as I noted, run it against the dev app server. The Python one is single-threaded, so if you use the default number of threads 4 and have lots of data, it will actually die partway through. We should probably automate this so you don't have to do this, but you can specify num threads equals 1. All right, so those are some sort of tips, tuning, running it. Let's talk about troubleshooting for a bit. So as I mentioned earlier, when I showed you the web XML and the app.yaml, the remote API URL is frequently configured wrong. It should say the request did not contain a necessary header. It's kind of a goofy error message. It's just saying that your browser is not the remote API client, and you should be using the remote API client. But it's also not telling you, it also ensures that when you're logging in, you can log in as an admin, and it's configured correctly, and it doesn't say show the home page of your application, which it might do if you have the catch-all handler. And you also need to specify that using the remote API URL in the bulk loader configuration if you're using --URL. If you're using a Python application, you can actually just specify an app directory just like you do for the upload and download and all those other operations. It will actually automatically infer things for you. If you're a Java developer, at the moment, you have to use --URL. And so debugging the config file. So since the config file is sort of fairly clean format, it'll spit out error messages telling you line numbers and error messages. Hopefully they're helpful. Occasionally, if the actual Python file you're importing contains an error, it'll tell you there's an error on that line of the app.yaml. And that's just telling you that, in fact, there's an error in the Python file, which is referenced on that line. On import, you can run a dry run. So the dry run takes all of your data, runs it through all of the import transforms, but doesn't actually write it to the data store. So this is useful, particularly if you have validation. I didn't mention this. You can actually use a Python model to ensure you have validation. And it'll basically ensure that it can pass through your entire input file without actually writing any data. And of course, you can just point it to the dev app server for both upload and download, particularly small sets of data. Just always good practice. All right, so talk a bit about future directions. So addressing the pain. So the whole point of the bulk loader, of course, is to make your life easier when you're moving data in and out of App Engine. So I've just showed you some of the transforms today. You may have noticed someone that said transform helper instead of transform. That's because I wrote them in the demo app instead of in the actual SDK. We'll be adding more useful ones in the SDK. This is also an opportunity sort of for you, the general audience, or anyone to contribute, since the SDK is in fact an open source project. If you have useful ones, we're certainly open to them potentially. More connectors. So right now we only have CSV and XML connectors and this demo simple JSON one. We obviously want some ones which actually connect to real databases, perhaps using the standard Python database interface, so you can connect to multiple databases without writing your own connector or exporting data. And the real big one is server-side processing. So I've talked about this tuning and these errors you can get. On our roadmap are things like MapReduce and long-running processes, and we're investigating which of those sort of the most useful way of actually handling data entirely on the server. So this isn't useful necessarily if you're running a local SQL database connection, though I actually have some ideas on how to make that work too. It's particularly useful if you have an entire CSV file, you've exported your entire database. You should be able to upload it using the blob store API in App Engine. Here's a giant blob, a single HTTP connection. It's very reliable. And then we can run it on the application server, iterate through all of your data on the server side, and it's basically gets rid of the most common pain point people have with the bulk loader today, which is that something happens at some point during the transfer process, and you have to debug that and deal with that. All right, so just a bit of summary, Q&A. So just a reminder, the bulk loader runs on your workstation, transforms data, moves it to the server. If you don't want to do any configuration, you're just moving data, backing it up, moving it from one instance to another. We've got a zero configuration. We have an automatic configuration tool. So you don't actually have to write one of these bulk loader configurations from scratch, but we've got lots of helpers in Transform to help you make your life easier. And you can also write your own helpers, write your own connectors. And just keys are key to creating relationships if you have more than one table and you have an example, probably more complicated than the initial bulk loader, the initial guestbook example. All right, so I guess I've given you guys lots of time for Q&A. So if any questions for the microphone, I'm going to see if I can open the wave here. Any hope for a Java version? So let me ask you why, I guess why. Is it what? You don't speak Python, but that's one of the specific goals I mentioned, which is that you shouldn't have to speak Python to use this new configuration format. It's in YAML. I didn't actually mention what YAML is. Yet another, YAML is not a markup language, I think is its name. Anyway, it is yet another markup language similar to XML. And hopefully the create wizard will just create the wizard well enough for you that you don't actually have to do very much to it. One of the things which we've looked at is actually running this code using Jython on the Java SDK, so at least you don't have to download Python, download the Python SDK. We've looked at it. I don't have actually anything to report interesting about that at this time. Cool.
Thank you for the presentation. So I have a same kind of question top of that. So is there any limitation for the file size to upload? So
that's why I said that is the biggest pain point right now. So we've changed some of how the scheduling works in App Engine so that you can upload a little bit better than that. Unfortunately, right now you do have to tune it, and it's still much slower than we'd like. So I'm going to be looking a little bit at the performance of it in the future, but sort of my big hope is actually that really soon we'll be able to actually say, instead of uploading the data piece by piece, which is why it takes so long, is it's this tons of overhead on every request, that we can just upload it to the server all at once as one giant blob and use, say, the map functions to run over it, and they'll run much quicker because instead of this giant overhead for every single little bit of data, it's all quite close to each other.
So your answer is currently
right. Unfortunately, it's still pretty slow right now, and
slow, you know.
It's slow, and yeah, exactly. I mean, I've certainly seen people with that sort of rate of speed, and certainly I've seen stuff go much faster than that too.
And is there any limitation about App Engine has a 30-second rule per one request, right? So is that the case applied to the?
So that's part of why the bulk loader runs on the client today, is because App Engine can't currently handle large amounts of data. It can now. It couldn't when this was originally created. It can't handle dealing with large amounts of data, and it can't handle requests longer than 30 seconds. Mm-hmm. So right now, that's why the bulk loader runs on the client. You can talk to it, whatever your client can handle amount of data, and it sends it bit by bit to the server using the remote API, which is why some of the cool new features we have dealing with MapReduce or long-running processes will actually alleviate that, but they're not there right now. So
you're planning to improve that kind of performance?
Yeah, that's specifically something which I'm actually really excited about those features, is because it will let us solve this problem.
How quick you release that kind of function? Time schedule?
Hopefully soon. I can't really say anything about time, but it is real. It's not vaporware, but I don't have any specific timing.
Okay, thank you.
Yeah. Hi, I'm curious if you're planning to do some graphical user interface. I don't know if you're familiar with an application called GEA bar that makes your backup and restore with a web interface. So is that something planned or not? Just stick to the command line?
There's no plans for that at this time. So.
Okay, thanks.
Yeah. All right, so talked about this question. So I don't know the details of how EC2-based databases work, but the fundamental answer to this question is pretty much the same answer you get to any question about how do I deal with data inside and outside of App Engine, which is that everything's an HTTP request. So the way the bulk loader works, it uses remote API to transfer information from your local client to the server. But as I said, you can imagine a connector. It runs on your local workstation, connects to Amazon, and talks to the server. you can also imagine something running on the server using task queue or something which does an HTTP request to your Amazon instance and pulls in data back and forth. That's how it fit with the bulk loader, is if we can run it with the client which talks to Amazon or vice in either direction. Yeah?
A question about the merging. Right now, is the bulk loader, does it support the merging of the data? Like if I delete some data in my local, will it delete up on the server too?
So that's an important question. When I mentioned keys are key, I didn't actually go into detail of what I really meant by that. So the bulk loader, when it's running on either import or export, is only doing either reads or writes. So when it's doing import of data from your local workstation to App Engine, right? So it's importing to App Engine. That's the direction we're going here. It's doing a put for every single entity that's in your input source to App Engine. So if you've not specified any keys at all, App Engine will auto-generate the keys and it will be purely an append. If you specified a key for every single row in your data file, if they're all new, it'll be all new entities. If you specified a key which represents an existing entity, it'll be an overwrite. So there's no specific delete. That's one of the other features which people very commonly ask for in App Engine. How do I delete all of my entities for this kind? And the answer right now is you can run a task queue task over, and the answer in the future will be using some of the new technologies I've talked about. Cool. All right. Similar answer to the previous question, I guess. I'm not exactly sure how this applies to the bulk loader. This is more use SDC with HTTP. So SDC is the secure data connector. It lets you, if your application is inside your firewall, it's a tool which lets you communicate over HTTP through your firewall. Are entities written in order such that reference properties are always valid? So this is, again, why keys are key. If your reference properties, if you have a way of calculating your keys for every entity. So again, if you have a user and the email address is unique for the user, Wikipedia articles, and you've got a specific title for every article, anytime you have a reference to this, or even if you actually use the GUID which your database had generated, anytime you have a reference to this anywhere, you can use it. So it doesn't matter what order things are written in, because you can have a key which points to, you can have a reference property which points to the key in another entity, even though that entity doesn't exist. Now, if you try to dereference it, you'll get a failure, because it could try to get the entity, doesn't exist. But as long as you have created both entities, you've created both the parent and the child and the reference, by the time you actually come around to reading the information, it's there. So about ordering, the ordering is not strictly guaranteed on upload because it does stuff in parallel. On download, the ordering is strictly guaranteed. Another feature I didn't mention is that you can actually specify by default when you run through, I said downloads everything, it just runs through all of your data. Right now, it runs through it in key order. There's a property you can specify on the YAML where you can actually specify an arbitrary sort property. So if you have a bunch of auto-generated keys and you actually want to sort by email address, you can actually specify the email address should be the sort key on the output. Invalid characters. I don't know, someone in this room apparently asked this. Okay. Yeah, so the encoding, again, this is dry run's particularly useful for this. The connectors, both the CSV and the XML connectors, support multiple encodings. So if you use the default UTF-8 encoding and your data is actually Windows 1252, you're likely to get an error partway through your file. So this is where dry run's particularly useful, because it'll run through all of your input data. And when you hit the end, no errors, you're good to go. If it dies partway through, you've known before you even try to write to your data store that you've got an error partway through your file. All right, any other questions? Well, I guess the end of the day, and I guess you all are welcome to hang out, talk to me. I'll be here afterwards. I'll probably be around. I'm either here or in office hours tomorrow. Again, if you go to bulkloadersample.appspot.com, you'll see all the samples. I guess I'm just matthew.blain@google.com if you have any questions for me over email too. All right, thanks.